There is 3 roslaunch to launch in order to have everything working together. The first here launch the kinematic and the visual processing. The second is the RET model created by Gelson, and the third one is the Weber words. When you launch the kinematic, if you don't see what's on the screen right now, this means that there's 2 host code running. Then, for the RET model to work finally, you need to have the last 2 lines highlighted here. And for netbind to work, you need this line here. If an ellipse is detected, you can see it here in the ellipse viewer, and here is the output sent to the RET model. And here is the point received by the kinematic. This is a point, and here is the stimulation and the noise received from the RET model. You can see everything related to the RET model, so the seed, the amplitude received, whether or not the model has Parkinson, and then the outputs. So we can see here then the message sent to the muscle, then to the kinematic actually, which is first the stimulation and then the noise. And playing this command, you can see the joint motion in radiant according to time. Will be presented here the healthy motion and the related data. So here we can see we have the home position, that is 2018, 113 and 65, and the noise sent to each of those motions, which is almost none. Visual processing was launched, stimulation, RET model, kinematic, and now the end is moving. In the RET model terminal, we can see that a stimulation of 1 was sent and a noise of 0 was sent. Here it's highlighted. As saved in this file, in order, the PD flag, the PD probability, the stimulation probability, that is always 1 and 0, it's perfect, the firing rate of the cortex, the mean easy of the cortex, and the STD easy of the cortex are. In this file I saved all the joint orders sent to the simulation, all the submotions and the color of the ball and the noise. Here there is 16 submotion, and then the 17th is, well, the end goes toward the object with an offset, half offset, and then go down on the object. This is the 17th motion. There is an offset between the center of now hand and the fingers. That's why there is a 20 millimeters offset between the 16th submotion and the real object position. And the same is the y-axis. There is a 12 offset in order to reach and grasp the object. Now the model will have PD. The seed used by the RET model is always written before it began. Here we have a stimulation of 1 and a noise of 0.2 that is sent to the kinematic. We can see here all the submotion and the noise sent to 8 joints. Here is written the stimulation and noise, and then above, right above is written the kinematic position. With the last motion is with an offset of 20 millimeters in the x-axis and 12 millimeters in the y-axis, because the center of now hand is not the position where the finger are, and that's why. Then we can plot the finger motion as well as the shoulder motion, the shoulder pitch and roll, and then also the elbow roll, yaw and roll. We can well see the tremor until the end motion, and then we can see that the lifting has no tremor. The lifting begins at 4 seconds in this simulation. Then, as with the healthy, there is the object real position that is written here, manually written here, and then all the submotion automatically written in this file. It was divided here to be more legible and to be able to explain them. And here we have the PD flag, the PD probability, the stimulation, and then the mean firing rate, the mean EZ, and the STD EZ of the cortex R. On the left, we can see a null stimulation with a noise of 0.19, which corresponds to the last line of the file on the right. Here, as the PD probability is not 100%, the maximum noise was not sent, but another one, which is 0.19. And then this last run shows well what happened most of the time, that the PD motion doesn't succeed in grasping the object.